This is for UTOR Spec 2018 Exam 2 Model Choice Question number 6. Let's say complex number Z was A plus BI. That means minus Z will be AI plus BI squared, which is minus B plus AI. And then we add them together. Z plus IZ will be A minus B in the real plus A plus B in the imaginary. Okay, I call that A and I call that B. Therefore, in the imaginary, that's A and that's B. That's minus A and that's minus B. That's minus A and that's minus B. So that Z is AB. IZ is minus BA. And this is A minus B, A plus B. So I need to find the area of this triangle. I'm wanting this to be a right angle. So what my proof is, I know that that's a right angle because if you multiply by I, you are rotating 90 degrees clockwise. So I know that this is a distance of the square root of A squared plus B squared. And this is also the square root of A squared plus B squared. So that there is, if we add them together, we square them, it's the square root of A squared plus B squared plus A squared plus B squared. So it's root 2 square root of A squared plus B squared. If I look at this one here, it's going to be the square root of A minus B squared plus B minus A plus B squared, which is the square root of A squared plus B squared. And if I do the same with this, it's the square root of A minus B minus B squared, which will give you A squared, plus A plus B minus A, which is B squared. So it is. So this is also the square root of A squared plus B squared. And since that's 1 and that's 1 and that's root 2, that's a right angle and that's 45 degrees. So the area of that triangle is going to be a half times the base, which is square root of A squared plus B squared times the square root of A squared plus B squared, which is A squared plus B squared all on 2, which is the modulus of Z all squared on 2.